The classic T-shot projectile motion problem. In this problem, we're going to determine the maximum height and the horizontal distance, which is also called the range of a golf ball, hit at 21 meters per second at an angle of 25 degrees to the horizontal. Now, in my diagram, I draw that initial velocity of 21 meters per second at an angle of 25 degrees to the horizontal, and I break it into its two components. When you're doing projectile motion, you have to look at the horizontal motion and the vertical motion independently of each other. So I break that initial velocity into its two component vectors. The initial velocity in the y direction, which would be 21 sine of 25 degrees, which is equal to 8.9 meters per second, and the velocity in the x direction, which would be 21 cosine of 25 degrees, 19 meters per second. Now, it's important to note in the x direction, your acceleration is always zero, so that x velocity, the horizontal velocity, never changes for the projectile all through the flight. But for the y velocity, it changes by the acceleration due to little g, which is minus 9.8 meters per second each second downward. So to get the max height, I use what I call the fourth equation, which says 2 times your change in displacement times the acceleration, which in this case would be little g, is equal to my final velocity squared in the y direction minus my starting velocity in the y direction. I come over here and I solve for y max, and y max is that point where I'm going to be at my high point. What's important about y max is that at y max, your final velocity in the y direction will be equal to 0. And that's a key point. So when we come in here to solve for y max, that since that final velocity in the y direction is equal to 0, we have 0 minus 8.9, the starting velocity in the y direction, squared divided by 2g, so 2 times minus 9.8. That will give us a maximum height of 4 meters. Now, to get the range, there's only one equation that's valid for the range, and that's your change in displacement in the x direction is equal to the velocity in the x direction times time. I know what my velocity in the x direction is. That's 19, but I don't have the time. So to get the time, I'm going to have to come down here, and I'm going to use the fact that the ball hit the ground at the same elevation that it left the ground. So I know that my change in y displacement is equal to 0. Using this equation, your change in displacement is equal to your initial velocity times time plus 1/2 your acceleration times time squared. I substituted and rewrote over here. 0 would be equal to that initial velocity in the y direction, 8.9, times the time, minus 1/2 little g, 9.8 t squared. That simplifies down to 0 is equal to 8.9 t minus 4.9 t squared. I divide by t, and that knocks out this t here and that t squared there. So I can come over here and solve for my time of 1.8 seconds. Once I have that, I'm just going to plug it into this formula, and I did that right here. And we see the change in displacement would be the horizontal velocity, 19 times the time of flight, 1.8, and we get 34 meters. And there she is. Have a good day. I really enjoyed doing this. Hope to see you again. Give me some feedback.